Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how our brains learn and adapt when things around us change? Like when a familiar route suddenly has construction or a favorite song changes its beat. Our brains are amazing at picking up on patterns, but what happens when those patterns shift? How does our brain deal with the old and learn the new? This study dives deep into that exact question. The researchers here were really curious about how well our brains can learn the rules of the world around us, but even more so, how our brains handle it when those rules change. Think about it, we're constantly bombarded with sights and sounds, and we're always picking up on patterns without even trying. This ability is called statistical learning. It helps us understand language, focus our attention, and even predict what is going to happen next. But in the real world, things don't always stay the same. Traffic patterns change, languages evolve, and our environments are always in flux. So being able to adapt to these changes is super important. Most studies on this have looked at what happens after someone has finished learning, like giving them a test later. But to really understand how we adapt in real time, we need to watch it happen as it is happening. That is where this study gets really interesting. They decided to use two different ways to measure this learning. One was an online measure, which means they looked at what was happening while people were learning. The other was an offline measure, which is like a test taken after the learning period. They also wanted to see if this worked the same way in both seeing things and hearing things. So what did they do? They created a special kind of game. Imagine a stream of either abstract shapes on a screen or spoken syllables. These shapes or sounds weren't random. They were presented in specific pairs. For example, shape A would always be followed by shape B, and then shape C would always be followed by shape D. This is a regular pattern. Participants weren't told about these pairs. They just had to pay attention and do a task. Here's the twist. Halfway through the stream of shapes or sounds, the pairs would change. So maybe after a while it would be like a followed by B, then C followed by D. But then suddenly it would switch to E followed by F, and then G followed by H. The brain has to unlearn the old pattern and learn the new one. To measure learning as it happened, the online part, they had participants do something while watching or listening. They had to press a button as quickly as possible whenever they saw or heard a specific target shape or sound. The idea is that if you are really good at predicting what is coming next because you've learned the pattern, you should be able to react faster. Especially to the second item in a pair because its appearance is predictable. If you don't know the pattern, you'd be slower to react. After people went through these streams of changing patterns, they were given a test. They were shown different pairs of shapes or sounds and asked if they remembered seeing them in the streams and how confident they were in their answer. This is the offline test. Now for the results. This is where it gets really cool. They found some big differences between hearing things and seeing things. When it came to sound, like spoken syllables, people were pretty good at learning. Their reaction times got faster when they could predict the next syllable because they'd learned the pattern. This happened for both the first set of pairs and the second set, but there was a catch. They were just a little bit better at learning the first set of pairs. It seems like the earlier pattern had a slight advantage. This is what they call a primacy effect. The first thing you learn sticks a bit better. But when they looked at the test after the listening session, something strange happened. The test only showed that people remembered the first set of sound patterns. They really struggled to show they had learned the second updated pattern. It is like their brains learned it while it was happening. But that knowledge didn't seem to stick around for the later test. Now, let's look at what happened with shapes and things you see. In the online task where they were measuring reaction times during the actual stream, they didn't see much evidence of learning. People weren't clearly getting faster at predicting the next shape. This is puzzling, especially since they did see learning in the sound group. However, when they gave the after-the-fact test, the offline test, they did find evidence of learning for the shapes. People were able to tell the difference between the old pairs and new pairs for both the first and the second set of shape patterns. So their brains weren't showing us they were learning in the moment, but they had picked it up by the time of the test. This is a super important finding. It tells us that measuring how fast someone reacts during an activity is very different from testing them later. The online measures show us what is happening in real time, how the brain is actively processing and predicting. The offline measures show us what knowledge has been stored and can be recalled. And in this study, these two types of learning seem to work differently for sounds and for sights. For sounds, the learning was clear when watching it happen, but not as clear later. For sights, it wasn't clear when watching it happen, but it was clear in the later test. Think about what this means. When we hear things, especially the patterns in speech, our brain might be really good at grabbing that statistical information as it comes in. It helps us understand what is being said right now. But maybe that kind of learning isn't as strong for long-term recall compared to when we see things. On the other hand, when we see things, we might not be as quick to speed up our reactions based on patterns in the moment. But our visual system seems to be really good at storing that information for later use, for recognizing patterns even if we didn't show that faster reaction time while it was happening. The researchers noticed something else. People who were good at learning the initial patterns in sounds were also better at adapting to the new sound patterns. The same was true for sights. This suggests that being good at picking up the first set of rules helps you adapt to the new rules. It is not like learning the first thing makes you worse at learning the second thing. In fact, it seems to help. What are the limitations of this study? Well, the task was pretty specific. Participants were asked to press a button when they saw or heard a target. This might have made the learning more task relevant and perhaps even sped up learning in general compared to just passively listening or watching. Also, they tested all the streams at the end. Maybe if they had tested the sound patterns right after the sound stream and the shape patterns right after the shape stream, they might have seen different results for how well the patterns stuck around. Plus, the way they set up the pairs in the second part of the stream might have sometimes accidentally included pairs from the first part. This slight overlap, they found, could sometimes make it harder to learn the new patterns. Pretty neat, huh? So, what does this all mean for us? It suggests that our brains learn and store information differently depending on whether we're seeing or hearing. When we hear, especially language, our brain is very adaptable and processing information as it unfolds. When we see, we might be more about building a strong memorized representation that we can access later. It also highlights how important it is to use different methods when studying the brain, because online and offline measures can tell us very different things. This is super important because our world is constantly changing. Being able to quickly adapt to new information is key for survival and for navigating complex social situations and learning new skills. Future research could look into what is happening in the brain with brain imaging techniques to see which areas are involved in this flexible learning. They could also explore individual differences. Some people might be naturally better at adapting than others. And of course, real-world patterns are often not perfectly regular. They have some randomness. So, studying how we adapt to patterns that aren't always 100% predictable would be the next logical step. That is all for this episode of RUBIN'S Mind Lab. What do you think about these findings? Have you ever noticed your brain learning patterns differently for sounds versus sights? Let me know in the comments below. And if you enjoyed this breakdown, please give it a thumbs up and subscribe for more journeys into the fascinating world of psychology. See you next time.